The final part, really, just 2 slides. Again, this is called aphelion when we are away from the sun in July, and perihelion, wow, when we are proximate or close to the sun. Away, aphelion, proximate, close, perihelion. Now, let's look at our dates again, because we talked about them in the simulation, but we didn't really look at them closely. In the summer solstice, when our tilt is most directly toward the sun, we have the greatest energy in the northern hemisphere. Notice you can be anywhere in the Arctic Circle, 23.5 degrees away from the North Pole, and you'll still always be in daylight. Now, what path will the sun appear to take? As we rotate around, the sun will appear to move in a circle around you, which is really weird. Any of you who have ever been on vacation up to Minnesota or something like that, you know, in the summer, that summer it's pretty high, you know. Down in Arizona, we don't notice quite as much. If you've ever been to Alaska in the summer, it's just crazy. I used to live near the equator. Something weird. The amount of daylight and night really didn't change much. Maybe an hour. That was it. So this is June 21st or 22nd, depending on if we're in a leap year or not. This is the summer solstice. 3 months later, as we go around the sun, we come to the fall or autumnal equinox, September 23rd or 22nd. Energy is equal in both hemispheres. We're looking at the dark side of the Earth here. 3 months later, winter solstice for us, summer solstice for Australia and South America, South Africa. If you're inside the Arctic Circle, you will never see the sun on this day, but again, the penguins will. And 3 months later, here. Now keep in mind this entire path takes about 364 and a quarter days. So every once in a while, because it takes more than an exact number of days, we have to add in another day called a leap day. Here is a nicer drawing of it. Notice that the Earth's tilt doesn't change as we go around the sun. People often think that happens. Adults will do this. We're always aimed toward Polaris. It's just that we spin keeping the same angle. And folks, I think that's it. If you have any questions, just raise your hand and, well, it'll look really silly. Probably better just to write me an email. Thanks for watching.